Hey everyone, welcome back. We're going deep on artificial intelligence today. Seems like it's just everywhere you look these days, right?
It really is.
And you all sent in such a cool mix of sources for this one. We've got encyclopedia stuff, journal articles, tech websites, even a couple YouTube videos in the mix.
Oh, wow.
Yeah, so, there's a lot to dig into.
It's great to see that kind of range, though, getting at AI from all these different angles. Because the theory, the tech, the real world stuff, it's all connected.
Totally. And honestly, with all the buzz, right? Self-driving cars, AI writing poems, AI making art, it can feel kind of overwhelming.
It can.
So I think before we even get to any of that, we need to, step back, ask the super basic question, what is intelligence? How do we even define that, especially when we're talking about artificial intelligence?
That's a great place to start. Yeah, can't assume we all mean the same thing when we say intelligence.
Right.
Okay.
And one of the sources you sent, the Britannica article, actually had this really interesting example about digger wasps.
Wait, wasps?
Wasps.
Okay, did not see that coming, but you've got my attention. What do wasps have to do with AI?
So these wasps have this complex behavior. The female leaves food outside her burrow, right? Goes in to check for intruders, then comes back out and brings the food in.
Okay.
Sounds kind of smart, right? Like a security check.
Yeah, it does. It seems like it takes planning or awareness or something.
But here's the thing. If you move the food while she's inside, she'll come out, repeat the whole ritual again. Every time.
Really?
Yeah. You can do it over and over, and she'll never adapt.
Oh, wow.
So it's less about intelligence and more like a hardwired program.
Okay, so it's just a fixed routine.
Exactly. And that's the key. True intelligence, it means being able to adapt to new situations, to learn and adjust your behavior. And that's what's so tough about AI, right? It's not just building computers that do stuff.
Right.
It's about building computers that can learn how to do stuff, and in ways we might not have even thought of.
Okay, so adaptability is key. That makes sense. Now, that same Britannica article, it mentioned a bunch of different, aspects of intelligence, things that AI researchers are trying to, recreate. Learning, reasoning, problem solving, perception, using language.
You got it, a whole list.
Yeah.
And each of those is its own challenge when you're trying to build it into a machine.
Totally. So let's break some of those down a bit. I'm really curious about the learning part. How do you even teach a computer to learn? It's not like handing it a textbook and being like, okay, memorize this.
Nope.
Right.
Definitely not. One of the biggest hurdles is teaching AI to generalize.
Okay. What does that mean?
It means it can take what it learned in one situation and apply it to something totally new. Think about how you learned grammar. You didn't memorize every possible sentence, did you?
Definitely not. I'm still working on all the grammar rules, honestly, right?
What you learn the rules, and then you apply them to new sentences, new situations. AI is still really struggling with that kind of flexible thinking.
That's a good point. We take our ability to generalize totally for granted. Okay, so what about reasoning? How does an AI, actually reason about things?
So there's two main types of reasoning that researchers focus on.
Okay.
Deductive and inductive.
Got it.
Deductive is all about logic and certainty. If A is true and B is true, then C must be true.
Okay, so very rule-based, straightforward.
Yeah, like solving a logic puzzle.
And inductive.
Inductive is more about probability. It's looking at evidence and drawing conclusions that are likely but not guaranteed. Think of a scientist making a hypothesis, right? They're using observations and data to make a guess about how something works.
Okay, so if I'm getting this right, deductive is like a computer proving a math theorem, and inductive is more like it predicting the weather.
Perfect analogy. And different AI applications, they need different types of reasoning. So something for medical diagnosis, that might use inductive reasoning to weigh different possibilities.
Oh, that's really interesting. That makes a lot of sense, yeah, for something like that, when you have to consider so many factors. Okay, so we've got learning, we've got reasoning. What about problem solving? How does an AI actually go about solving a problem?
One common way is called means-end analysis.
Means-end analysis?
Yes, where the AI breaks a problem down into smaller steps. Imagine a robot trying to get through a maze, right? It starts by figuring out, okay, where am I now and where do I want to go?
Okay, yeah.
Then it breaks down the path into those little actions. Move forward, turn left, turn right, whatever it needs.
It's like that saying, how do you eat an elephant? One bite at a time.
Exactly. Break it down, make a plan, execute it step by step.
I like it. Now, I remember the Britannica article mentioned that there are these different approaches to actually building AI, almost like competing schools of thought or something. Something about symbolic versus connectionist AI.
Yeah, you got it. Like two different ways of creating that AI brain, so to speak.
Hmm.
The symbolic approach, sometimes called top-down, it's all about rules and logic. It's like programming. You give the AI a set of instructions, tell it exactly how to process information.
So it's like writing a super detailed recipe for intelligence.
That's a great way to put it. Then you've got the connectionist approach, or bottom-up. This one's inspired by the human brain, using artificial neural networks.
Okay.
Instead of programming rules, you train these networks on tons of data, and they learn to recognize patterns, make connections on their own.
So if we were building that like alphabet recognizing AI we talked about before, how would these two approaches play out?
Okay, so with the connectionist approach, you'd show the neural network like tons of examples of letters, right?
Mm-hmm.
Let it adjust itself to figure out the patterns. What makes an A different from a B?
Okay.
It's like teaching a kid with flashcards, showing them examples.
Got it.
With symbolic, you'd program in the geometric descriptions of each letter, like defining the rules for how to recognize it. More like teaching by explaining the shapes.
So it's like the difference between learning from experience versus learning by like direct instruction. That's a great way to think about it. But I'm guessing both approaches, they have their limitations, right?
I do. Symbolic AI is great for things with clear rules, but it struggles with the real world. Because the real world's messy, it's complex.
Right.
Connectionist AI is better at handling that messiness, but it can be tough to understand how those deep learning networks make decisions.
Ah, so it's a bit of a black box situation.
Hey, kind.
Okay, so it's like we're still figuring out the perfect recipe for intelligence, even though we've got all these cool ingredients to work with. But even with those challenges, it feels like AI has made incredible progress just in recent years, right? I mean, look at all the stuff we're already talking about.
Oh, for sure. And a huge part of that is the growth in computing power, what we call Moore's Law. Basically, computing power doubles about every 18 months, and that's still going strong.
It's wild.
And that lets us process these huge amounts of data, what we call big data.
It's mind-blowing how much data we're generating these days.
It is.
I remember reading that the language model behind ChatGPT was trained on something like 45 terabytes of text. It's just enormous.
Huge.
And that brings us to another big idea, machine learning.
It does. Machine learning is all about training algorithms on data. Like you can find patterns, make predictions.
Right.
But even within machine learning, there's this one approach that's been stealing the show. Deep learning.
Oh yeah, deep learning. That's the one that's been making all the headlines. What makes it so special? Is it just like another type of machine learning?
It is a type of machine learning, but what sets it apart is using neural networks with like many, many layers, just like the human brain.
Ah, okay.
And these networks can learn crazy complex patterns from raw data. Imagine a neural network with layers that each analyze different things in an image. Edges, shapes, colors, textures. Each layer adds another level, building up this sophisticated understanding.
So it's like each layer's adding another piece of the puzzle until you get the full picture of what the AI is like seeing.
That's a good way to think about it.
And I remember reading that these deep learning networks can even learn without being explicitly programmed, what they call unsupervised learning.
That's right. And it's a huge breakthrough. With unsupervised learning, the algorithm can find features and patterns in the data without needing labels or instructions beforehand. It's basically learning to see the world and make sense of it all on its own.
Wow, that's incredible. But all of this amazing tech, all this learning and problem solving, it's not just happening in labs anymore, is it?
Nope.
AI is out in the world actually doing stuff.
It is. And that's what we'll look at next.
Huh?
The real-world impact of AI. From games to medicines, from art to everyday tasks, AI is changing how we live, work, interact with the world. And I think it's safe to say it's only going to get more wild from here.
Okay, so we've talked about the building blocks of AI, how it learns, reasons, solves problems. Now I'm ready to see it in action. Where are we seeing AI really making a difference out in the real world?
Well, one area that always captures people's imaginations is how AI is changing the world of games. You mentioned Deep Blue beating Kasparov at chess back in the 90s.
Yeah, it felt like such a turning point, you know.
It was.
But chess is a game of logic and strategy. What about games that are more about intuition, creativity? Like, could AI ever master something as complex and nuanced as Go?
And that's where DeepMind's AlphaGo comes in. It actually did master Go. a game with just a mind-boggling number of possible moves.
No way. I remember hearing about that, but I never really understood how it worked. Did they, like, feed it every Go game ever played or something?
But the amazing thing is that it learned mostly by playing itself, millions and millions of times, using a technique called reinforcement learning to get better and better.
That's wild. So it basically became a Go master by playing against itself. It's like it created its own training ground. That's like next level learning.
It is.
Speaking of learning, what about image recognition? I know AI is getting really good at identifying things in pictures and videos.
Absolutely. And the real workhorses behind that are convolutional neural networks, CNNs.
CNNs,
Oh,
yeah.
They're trained on these huge data sets of images, so they can learn to recognize patterns, features that even humans might miss.
One of the sources even mentioned this network called PILUNet, developed by Microsoft Research.
Right.
And they were saying it could actually outperform humans in some image classification tasks. Is that, like, even possible?
It is. In certain areas, we are seeing AI systems doing better than humans, like identifying certain types of skin cancer from images.
Whoa. That's both amazing and a little, I don't know, unsettling. Like, it makes you wonder what other human tasks AI might end up surpassing us in.
For sure. It's a question a lot of people are asking.
Yeah. Okay, so AI is playing games, diagnosing diseases. What else? What are some other areas where it's making a real tangible impact already?
Well, think about drug development. Pfizer actually used machine learning to help develop Paxlovid, their COVID treatment.
Oh, wow. So AI is literally helping to save lives?
It is.
That's incredible.
And it goes so much further than just healthcare. Google uses machine learning to filter spam from our inboxes. Banks use it to detect fraud. The list goes on and on. It's really getting woven into, like, the fabric of our digital lives.
Okay, but what about these deep fakes everyone's talking about? Those feel a little more on the concerning side of things, to be honest.
Deepfakes are definitely fascinating and
Yeah.
potentially unsettling, yeah.
Yeah.
They basically work by setting two neural networks against each other.
Okay.
One's trying to create these realistic fakes, images, videos,
Yeah.
and the other's trying to spot them. It's like an AI arms race, each one pushing the other to get better.
So it's this constant back and forth, the fakers and the detectors, like, trying to outsmart each other.
Exactly. And the results can be incredibly convincing. Remember that image of the Pope wearing like a stylish puffer jacket that went viral?
Oh, yeah, I remember that. Everyone was talking about it. And then there was that video that looks like a certain former president was being arrested, but it turned out to be totally fake.
Right.
It's crazy how real they can look.
It is. And deepfakes really highlight that, like, double-sided nature of AI. It can be creative, but also deceptive, entertaining, but also, used for manipulation.
It's definitely a double-edged sword. Now, one area that's really on my mind, and I know it's on the minds of a lot of our listeners, is AI's impact on language, on communication. I feel like we're in the middle of a major shift.
You're right. We've come a long way from those early chatbots, the ones that just followed basic rules.
All right.
Now we've got these probabilistic and deep learning approaches that are really changing how we interact with language.
And I think the biggest game changer has been those large language models, LLMs, like GPT-3, ChatGPT.
Yeah. LLMs are incredibly powerful. Just the sheer scale of them is mind-boggling. We're talking about models with billions of parameters trained on terabytes of data.
Yeah, one of the YouTube videos we watched, it said that a single ChatGPT query can use like 10 times more electricity than a Google search.
Wow.
Which is kind of insane to think about, right? Both from like a processing power standpoint, but also the environmental impact.
Yeah, it's definitely something to consider. The energy consumption of these models is a growing issue.
For sure.
But going back to LLMs, ChatGPT especially, it really sent shockwaves through so many fields, showing just how good AI can get at generating human-quality text.
And it started all these conversations about the future of writing, creativity. Some people are excited, some are worried.
It's complex.
Right.
Lots of unknowns. And then you've got the problem of LM hallucinations,
Oh, right.
where they make stuff up that sounds plausible, but is actually just wrong.
Yeah. Like when you ask it for a historical fact and it just like invents something that fits but is totally made up.
Exactly.
Yeah.
Researchers are trying to figure out ways to minimize those through techniques like prompt engineering, where you carefully design how you ask questions to get more reliable answers.
So it's not just training the AI, it's training ourselves to like communicate with it better.
Exactly.
Interesting. Okay, but beyond language, AI is changing so many other parts of our lives. What about self-driving cars? Those feel like they've been just around the corner forever, but I still don't see them on the roads that often.
Self-driving cars are a great example of AI pushing the limits of what's possible. But the challenges are huge.
Yeah, I can imagine.
These systems have to navigate real-world environments with unpredictable human drivers, make split-second decisions where safety is everything.
Right. It's one thing to program a car to stay in its lane on an empty highway, but to understand all the little things humans do in traffic, all those judgment calls we make without even thinking.
Exactly. And that takes massive amounts of data, complex algorithms, years of testing in all kinds of conditions.
One of the articles talked about Waymo, Google's self-driving car project. They've been testing for a while, but there are still reports of accidents, near misses.
It's a reminder that even with all the progress, we're not there yet.
Huh.
Fully autonomous vehicles are still a work in progress.
Okay.
Lots of technical and ethical stuff to figure out.
Speaking of things becoming more common, what about virtual assistants? It feels like Siri, Alexa, all those customer service chatbots, they're just part of life now.
It's been a pretty remarkable evolution, yeah. From those early text-based chatbots to these voice-activated assistants that can understand your questions, respond to commands.
They've gotten so much more sophisticated.
They have.
And the rise of smartphones really helped that along, right? Suddenly everyone had this powerful computer in their pocket. It was like the perfect platform for these assistants to take off.
Absolutely. Smartphones gave them the ecosystem they needed to thrive. But even with all this talk about AI's potential, all the cool stuff it's doing, we can't ignore the downsides, can we? Like job displacement is a big one people worry about.
Yeah, for sure. If AI gets better at automating things, some jobs are definitely at risk, especially the ones that are repetitive or very rule-based.
You're right. And it raises these questions about how do we prepare for a future where AI plays an even bigger role in the workplace? What skills will be in demand? How do we make sure everyone benefits, not just a select few?
One article even had this kind of cynical joke that AI sometimes stands for actually Indians, referring to how some tasks that were supposed to be fully automated actually rely on outsourced labor.
That's interesting. It highlights how important transparency is and ethical considerations in how we develop AI.
Yeah.
We can't just focus on the tech advancements. We've got to think about the social and economic impacts too.
It's not just about the tech itself, it's how we use it.
Exactly. And these are the kinds of conversations we need to be having as a society because AI is going to keep evolving. It's going to keep impacting our lives in bigger and bigger ways.
It feels like we've covered so much ground in this deep dive.
Sure.
From tiny wasp brains to massive data centers and everything in between. It's amazing how AI is already touching so many parts of our lives.
It really is a transformative technology.
Right.
With the potential to change whole industries, redefine what's even possible. But as we've said, it's not all, sunshine and roses.
Right.
There are real challenges with AI that we need to think about carefully.
So where do we go from here? What does it all mean? How do we navigate this uncharted territory in a way that actually benefits everyone?
Those are the million-dollar questions.
Yeah.
And there are no easy answers. It's going to take all of us, really. Researchers, policymakers, industry folks, and just everyday people like us to shape the future of AI in a way that's good for humanity.
One of the sources we looked at, a report from the UK's National Health Service, they were talking about the need for a digitally ready workforce. People who can embrace these new technologies, adapt to them.
That's so important.
Yeah.
We need to be ready for a future where AI is just woven into so many things, our work, our personal lives, and that means being open to learning new skills, new ways of working.
It's not about being afraid of AI or trying to stop progress.
Right.
It's about understanding what it can do, what it can't do, and working together to make sure it's used ethically, responsibly, that it's used for good.
I agree. We have to have these open, honest conversations about what AI could mean for jobs, for privacy, for equality, even for the environment. And we need rules, regulations that encourage innovation, but also protect us from potential harm.
One of the most thought-provoking things I read during all this research was this quote from Marvin Minsky, one of the pioneers of AI.
Oh, yeah.
He compared intelligence to unexplored regions of Africa, saying it disappears as soon as we discover it.
That's a great analogy. The more we learn about AI, the more we realize how much we don't know about intelligence, human or artificial.
Right.
It's a constant process of discovery, of rethinking what we thought we knew.
It's humbling, for sure. But it's also super exciting. We're at the start of this whole new era of technology, and we have a chance to shape it, to make it work for everyone.
We do. We need to approach AI with curiosity, but also caution.
Yeah.
and a really deep sense of responsibility. Because the choices we make now, they're going to determine what kind of world we create. A world where AI can be a force for good, for progress, for solving some of the biggest problems we face.
Well said. And on that note, I think we'll leave our listeners with a final question to think about. If AI can write poetry, compose music, create art, even help develop life-saving drugs, what does it mean to be human in a world where machines are getting smarter and smarter? What makes us unique? What are our values, and how do we want to shape our future alongside these powerful new tools?
Those are the questions we all need to be asking. The future of AI, it's not set in stone. It's up to us to create it.
Thanks for joining us on this deep dive into the world of AI. We hope it sparked your curiosity, maybe challenged some assumptions, and maybe even left you with more questions than answers. Until next time, keep exploring, keep learning, and keep asking those big questions.